everybody. My name is Nick. I am here with Benten Engineering, and I'm here to show you one of the many cool things we do here. Today we're going to be setting up a vision system with a Yaskawa arm to correctly pick a part that we are tasked with picking. And so the part itself is somewhat complicated. It is a clear plastic tube with embossing on one side or characters. We need to pick it in a certain orientation with the characters facing upwards. And so I'm going to be walking you through today how we're setting that up and how we're going to get it to correctly pick and identify these parts. So the first thing we're going to be doing before we start is we're going to want to check this share calibration data across programs box. What this enables us to do is give a unique data ID to the calibration data we're going to do when we actually calibrate the system. What this allows us to do is to call calibration data from multiple programs. That way we're not calibrating the same arm multiple times. It really does come in useful. It's very practical. So once we have that, we have it set to pick currently. It's a fixed pick. It is on a fixed platform. So we're going to be selecting a fixed pick, and we share calibration data across programs. So once that is done, we will click execute, and we will save the settings, and that will bring us here to our new program page. And pretty much from the beginning, what we're going to want to do is, or what we're going to see is the easy setup menu here. And so it makes it pretty easy. We have 5 steps here to complete. Once you complete all 5 of these steps, you're done, and the robot should be able to autonomously pick your part. So the first step we have here is setting the camera that we're going to be using, and the camera settings as well. So it should automatically pick up the model camera you're using if you are connected. Right now we're using a CA200M. As far as the size goes, we don't touch that. We leave it. You can play around with it. It does change a few things, but we have it on 1600 by 1200 progressive. So we're going to leave it where it is. As far as the shutter speed goes, the shutter speed is what is allowing light into the camera, how much light is being allowed in. And so right now it's set to 1/500th, and you can see the three pieces, the 3 parts we have currently in our field of view. They are pretty bright, and you can see them pretty well. And what we can do is, if we were to raise this up to 1/1000th, you could see the picture instantly gets darker. And so depending on the part that you need picked, you can play around with this as much as you want. You can also play with the sensitivity here. Raising the sensitivity will allow more light in, whereas raising or lowering the shutter speed will allow less light in. So you can play with that to your heart's content, and depending on the circumstances needed, you can mess around with that. The one thing that we do want to add, though, is HDR. Once we check this, we get a much cleaner, more monochromatic image, which allows for better feature extraction. Okay, so once we are done actually setting up the settings for the camera and getting a good image that we want and we're okay with, we can click OK. And the next step, step 2, would be to set the robot connection. We want to make sure that the arm that we're using is properly connected to the vision controller and that they can communicate with one another. So if we click over here, set robot connection, you can see the manufacturer we have set as Yaskawa, because we are using a Yaskawa arm. And our communication mode is Ethernet. We have an Ethernet cable connecting the arm to the vision controller. And if you have an Ethernet cable connecting them, and we head down here to the CVX communication settings, these network settings should be automatically populated once you are actually connected. If not, you'll want to find out this information, the IP address and everything else, but it should automatically populate if you are connected with an Ethernet cable. So we'll click OK there, and the first thing we're going to do is right under Network, there's a check connection. We're going to check the connection, and we'll put in the robot's IP address, and we're going to ping it. We're going to make sure that they're able to talk to one another. So it succeeded in verifying the connection with the robot, which is great. We'll close that out, and then the next thing we want to do is we want to check the robot operation validity. What this will allow us to do is actually operate the arm through the program here, the vision program. If you can see down here, there is a little robot operation button. So once we check the operational validity, which it has been verified that the setup program is running, and it can be operated from the CVX, which is our vision controller. So once we have confirmed that that is operational, we can go down here to robot operation. And as you can see, we have our X, Y, Z, and our rotational X, Y, Z. So we can fully operate the arm using the program. We can move it in the X, Y, Z, whichever way we want it to move. We can change the moving speed and the coordinate system that we're using. Now, the one thing that I do want to note is up here, the 3 tabs, we have jog, value specifications, and position data. Jog is to operate the robot manually. Position data is very important, at least in my opinion. We can set different positions and we can save those positions. And so if we, let's say Vision Home, I already have one set called Vision Home. If we've moved the robot to a certain position and we don't want it there anymore, instead of manually having to move it back, we can simply turn on Vision Home and then click and hold move, and it'll continue and it'll move to that position. Now, since the robot is currently in that position, it says moving complete the second I pressed it. But if you press and hold, you can move the robot to that position or whichever position you have it set to. Okay, the next step we're going to be working on here is actually calibrating the system, making sure that we have precise picks and the arm knows where it's going and where it can go. So the third step here, calibration, we'll go ahead and click on that and get in there. And so the first thing we're going to want to do is actually, if you can tell, I went ahead and I put a piece of tape with a B for Benten Engineering on here. You want to use a dark featured asymmetrical design, anything. It could be a smiley face, an A, a B, a lettering, numbers, anything that is asymmetrical and very distinguishable. So as you can see, the vision system has no problem picking this up. And so the first step that we want to do is we want to get the robot's coordinates or the start position for the calibration. So whatever position the robot's currently in, you want to have it in the field of view of the camera, which we do. You see our arm right here. And so what we're going to do is we're going to get the robot coordinates right here. We'll click that, and that'll get all our coordinates, where it currently is and where it's positioned. And then we're going to click register. Once we register those robot coordinates, we click next. And this is detecting our tool. So you'll see we're using a pattern tracks for calibration. Pattern tracks is the software tool for identifying specific patterns, and so we're going to be using that. Right under that, you'll see the edit tool button. We're going to go ahead and click edit tool, and it's going to ask for an image registration. You simply click register, and it'll register the current image on the screen, and that's what we want. We want to register this image because this is what it's looking for. And keep in mind, this is only being used for calibration. So we will go ahead and register that. It'll save that image. And then we will click OK. And now what we want to do is we want to edit the pattern region. We want to tell the vision system what it's looking for, what specific pattern it's looking for. So this green rectangle, we're going to go ahead and grab it by the edges, and we're going to surround our B here and try and get it as tight as possible because we don't want it picking up anything else. There we go. So once we have that, you see I'll zoom in, we have our pattern region around our B. So this is what we're looking for. And again, this is only being used for calibration. This is what it's using for the calibration. So we'll click OK here. And then you can mess with these settings, but for calibration, there's no need to. We'll get more into this later on. We'll go more in depth into all these settings. So we'll go ahead and click OK. And so now what we're going to do is we're going to execute our calibration. So there's multiple movement patterns that you can select. If we go into the calibration settings here, you'll see that I can set my movement pattern for 3x3 or 5x5. We're going to keep it on 3x3, and then the movement interval as well. How far it moves in between each point. I have it set to 40 millimeters as our space is limited. That can be set to whatever is needed. So we're gonna go ahead and set that to 40 millimeters, and we're not going to touch anything else. We'll click OK. Now we just click execute, and we sit and let the system calibrate. So we'll do it completely autonomously. You just have to sit and wait for a little bit and wait for it to finish the calibration. And now that the calibration is complete, we will go ahead and click next, and we'll calculate the tool center position. And so once again, we just simply click execute, and the system will calculate the center position of the tool. And just like that, we have the system calibrated and ready to go. Now we are ready to go into pattern tracks for object detection. We're going to actually be teaching the program what is a good pick and what it should be looking for. So right here, step 4, pattern tracks for object detection is what we're looking for. So we'll click at it, and that'll bring us in. And so you'll see, notice right away that it asks for image registration. And so we need to take an image of what a good pick is, so that way it can use that as the reference image and compare that to any pieces that are on there. So you always want a reference image, and we want to teach you what is good and what is not. So what we're going to do, I already set up a piece that we're looking for, so we're going to register this as our reference image, and all we'll click is register, and it'll save the image, and then we'll click OK. And now it wants us to edit the pattern region. What exactly is it looking for? What are we looking for? And so you have a bunch of different options for the pattern region. You can do rectangle, rotated rectangle, circle, oval, ring. We're going to do a rotated rectangle, that way we can actually move it around. And so here what we're going to do is we're going to set it up so that we can perfectly outline the piece we are looking for. So we'll grab the corners here and we'll bring them in. We're going to want to give it a little bit of room to breathe. So that way we're not running into other pieces in case they're in close proximity to one another. And so this way, now the system knows what it's looking for. Now we want this embossing to be right side up, but we'll get to that in a little bit. So we'll click OK there. So now the system knows what it should be looking for. It knows that this is a good pick. So next what we're going to do is we're going to apply some filters so we can better extract some of the features of our part. Okay, now we're going to be trying to enhance the image with filters that are available in the Keyence program. So what we're going to do is, up here you see 4 different options: search region, pattern region, extract colors, image enhance. We're going to want to go to image enhance. And you can see execute filter type. So all we click is add. And we have a list of filters for all types of different purposes. We're going to be using two that I've found to work really well. We're going to be using shading correction, which you can see gives it almost a monochromatic finish. So we're going to add that one. And you see every filter has its own setting, so you can tweak the filter as well. So it goes really in depth. You can do whatever you want to do with these filters. Then we're going to add one more, expand, which brings out more of the white particles, because we're trying to bring out the embossing on these parts as much as possible. So we'll add that. Okay. You can see the system still picks it up. It's still picking it. It's still recognizing what we're looking for. It's just we have a more clear image. You see now it's a lot more defined. Our edges, our characters, what we're looking for is a lot more defined. So now we are able to play around with the system using these filters and program it or set it using these filters as the conditions. Okay, so once you've found the filters that work for you and you've had time to play around with the filter settings and get a clear-cut image of what you're looking for, we actually get into the detection conditions. So the detection conditions are conditions that limit the system on what can be detected and what cannot, what is a good pick and what is not a good pick. So there are a lot of different detection conditions. You only see 3 here currently, but we can go further into that. But let me go over these 3 first. So we have angle range. So mine is set to plus or minus 180 degrees, which simply means no matter which way this part is oriented, the system will recognize it as a good pick as long as it is right side up. Under that we have detection count. Mine is set to 3, which simply means that it can detect up to 3 parts at a time. If we were to set this to 1 and I had 5 parts on here, it would only detect 1 part. So now that it's on 3, I can detect up to 3 parts at one time. And then I think the most important detection condition here is the minimum match percentage, which right now mine is set to 75%. What this does is it calls to the reference image and it gives a percentage to the current image here. So right now we're on our reference image, and so you can see that up here it gives us a match percentage of 99%, 99.607%. So since I have the minimum match percentage set to 75%, anything under a 75% match to this reference image will not be recognized and will not be picked. Anything above this will be recognized and will be outlined by the system. Now if we go further into detection conditions by clicking the double arrows up here, you can see we have the same conditions we were just looking at, and then we have a few more. You can the detection order, right? You can change that, how it organizes them in terms of detection. We have our timeout in seconds for the program. And then here we have minimum distance, which is also a very important condition. Minimum distance simply means that any parts within 30 millimeters, within 30 millimeters of each other will not be recognized. So this is in millimeters. So anything within 30 millimeters of each other will not be recognized. Any parts that are 30 millimeters or more apart will be recognized and will be outlined by the system as a good pick. And we have our feature extraction conditions, which we're able to set a detection mark, which is what we're going to be playing around with. So the detection mark tells the program to search for a certain mark or feature on the part. So if we set a detection mark, and we can choose the shape again, we're going to do rotated rectangle. And what we're going to do is we're going to rotate that to embody our lettering, because what we want on this part is for the lettering to be face up. We want it to be picked in this certain orientation with the lettering or embossing face up, so that it can be placed in a certain orientation as well. So what I'm going to do is I'm going to take the detection mark and I'm going to make it hug the lettering as tight as possible. We don't want to get any of the outer edges in there. And so now we have the detection mark looking around our embossing right here. So we'll click OK. And now what you can do is you can actually set the feature extraction size. So if we uncheck this auto tuning, you can see the feature extraction size in pixels. And so what that's doing is once a certain amount of pixels is detected, it'll show that as a good pick and it'll pick it. Anything less than that and it will not pick and it will be registered as no good. And so that's something that we really want. As far as accuracy goes, I'm going to change it to high so that we have a better chance of getting correct positive picks, because we don't want any false positives or false negatives. And we will go ahead and click OK there. And then you also have, of course, judgment conditions, which judgment conditions are conditions on whether or not it will be a good pick. This is same as detection conditions, in fact. It's just a little bit more in depth. So you have count, upper limit, lower limit, how many it's detecting. Position, you can set an XY position, so if it's outside of a certain X or Y position, it will not be registered as a good pick. You can set an angle limit. Your limits are 30, positive 30, negative 60. You can set that here, and so anything outside of that range will not be picked. And then, of course, match percentage. You can set a lower limit and an upper limit to match percentage. So once we're done with all the feature extraction conditions and the detection conditions, and once we're able to confirm that the system is correctly picking these parts, we're done with pattern tracks and we can move on to the next step, number 5, which is picking using the actual arm. And so I already have this set up. If we go into edit here, and we can go into edit. And so you can see we're calling the calibration data from earlier before, the calibration data that we set up. We're calling that, and we're also calling the pattern tracks for object detection that we were just working on, so that so it can pick the correct parts and call for the arm to come down and grab them. The one thing we do want to tick is multiple detection. Now this is circumstantial, but for our circumstance, we want to be able to detect multiple at once. And so we're going to click multiple detection, and I have it set to 3 again. Once that is done, we can head to the next part. And the next thing we want to do is we want to set the object position coordinates. So what we're going to do is we place the object or the part that we are wanting to pick, we place it in field of view of the camera, and then we'll bring the robot arm down exactly how we want it to pick that item. So as you can see, we have our part in the correct position that we want it to be picked, and you can see we have a little yellow cross, which means it is being picked up by the vision system. And we have the position coordinates already set up, and our master position image is set as well. This is our master position image, which is simply a reference image for our picks. Once that is done, we can move on to our judgment conditions, which is different from our detection conditions. The judgment conditions are judging whether or not the arm will pick this or not. So you can set an X, Y, and a rotational angle limit. So anything outside of those limits will not be recognized and will not be picked. And so once we are done there, we are completely done, and we can move on to verifying the operation flow. Now we are going to verify the operation of the arm and make sure that it is picking correctly and accurately. So I currently have one piece out here, and the vision system is picking it up correctly, and it is calculating the path to the object. Now we just need to make sure that the robot is able to pick it correctly. So what we will do is we will head over to verify operation. You can see there is an operation flow, so what will happen is the system will pause for 1 second, 1,000 milliseconds, and then it'll issue a trigger to the camera, which will then take a photo, and then if it detects a good pick, it'll send a signal out to the robot arm, which will then move into the detected position and pick that item. So we'll go ahead and click operation, execute operation flow, okay, and then we will go ahead and click and hold execute. So the operation flow execution is finished and the robot had a successful pick. So if we go ahead and click close here and then run, you can see that the robot did successfully pick it. It might be the arm might be obstructing the view a little bit, but it is a good pick. The robot successfully picked it, and so now we can go ahead and move on with programming the Yaskawa controller, so that way we can do this all autonomously without having to intervene here. And with that, we were able to successfully set up our vision system to correctly identify our parts, and we were able to set up the arm to correctly pick our parts in the correct orientation as well. Thank you everyone for watching this today, and we here at Benten Engineering are planning on putting out more videos like this. I hope everyone has a good day. Stay safe out there.